Nanomaterials is an interesting concept in materials science because of its many applications across a lot of different disciplines. So if we want to talk about nanomaterials, you have to understand the dimensions of nanomaterials. So when we're describing a zero-dimensional nanomaterial, what we're really talking about is we have three dimensions that are on the nanoscale range. So we have the length, the width, and the height that are all under 100 nanometers in size. And similarly, we have this first dimension, which would mean we have two dimensions on the nanoscale and then one macroscopically sized dimension. For a two-dimensional nanomaterial, we have two dimensions that are macroscopically sized, but then one dimension, which would be the depth here, on the nanoscale range. Some of the applications I'd like to discuss now would be how they're being used in antibiotics, some of the tribological applications of nanomaterials, some of the construction uses that we have, and the forensics and wastewater treatment. And traditional antibiotics are in danger of becoming obsolete due to higher resistance caused by bacterial mutation. And this can actually be remedied through use of nanomaterials since it's been shown that bacteria aren't really able to develop a resistance to these nanomaterial metals. So identifying the bacteria causing the infection is the first step clinicians use. And it actually has been shown that nanomaterials can detect exact species of bacteria uh, even as quickly as 20 minutes. One example of this is iron oxide nanoprobes, which have been used to identify strains of tuberculosis. So one specific nanomaterial is silver, uh, specifically silver nanoplates, which have been shown to be very effective against E. coli, and they essentially attack the cell by penetrating the cell membrane of the bacteria, which causes it to leak out its contents, such as the sugars and proteins that it needs to function. So, tribology is one area of science that studies how different surfaces interact with each other. And it's very important because the design of lubricants that reduce the friction between two surfaces is very important for designing machinery that doesn't wear out. Um, it's been shown that actually 80% of the machine failure is due to this friction. So, so one way that the nanomaterials actually mechanically function to lubricate their surfaces is if you look here at this object surface, it's very rigid and bumpy, and this is what leads to higher friction between two interacting surfaces. So what nanoparticles actually do is they're able to spread out between these gaps and form a much smoother surface for those interacting surfaces to slide together with. And one of the problems that stands in the way of this lubrication is that sometimes the particles aren't actually able to properly disperse themselves across the surface. And this is most of the time due to this electrostatic repulsion that can lead to particles sort of clumping up together. So to combat this, the addition of aluminum oxide can actually alleviate this due to its hydrophobic characteristics. So when it comes to construction materials, nanoparticles also have some applications in improving the strength and the longevity that we need when we want to build something with concrete or asphalt. So what's happening on the small scale with these construction materials is you have concrete here, and you have your aggregate materials with some regular silica particles in just dispersed evenly throughout it. But you still have a lot of empty space, which can lead to not as much strength and structural integrity. So the incorporation of the silica nanoparticles actually saves a lot more of that space and it is what helps to improve the packing and the strength of the concrete. Asphalt is another very important building material due to its ability to deal with large volumes of traffic constantly. But living in a northern climate like this, we see a very high and low temperature changes, which can cause the asphalt to weaken and lose some of its structural integrity. But luckily, some nanomaterial additions like aluminum oxide can reduce some of these weaknesses due to their hydrophobic abilities, which can lessen the moisture infiltration that can lead to some of the crack formations we see. So one area that we found nanomaterials have been very useful in is forensics. And this is because of how fingerprinting is done now with them, because it's been shown that with the use of nanomaterials to search for fingerprints, they're actually able to produce much higher resolution images than traditional dusting methods. And this is important because it allows analysts to better analyze what a fingerprint looks like and see if it's a match. Now, the way this works is that when a criminal touches a surface, their fingerprint leaves behind a residue, which is shown to contain some amino acids and fatty acids, which can actually still be detected for a very long time. And some of these silver nanoparticles can actually attach to these uh, acids and identify the patterns that the fingerprint leaves. So to wrap things up, I'd like to talk about wastewater cleaning and how nanomaterials can be used to help this. So it's been shown that some metal ions such as lead, nickel, zinc, chromium, copper, and cadmium, all these ions are have been found in small concentrations in water that we use every day for agriculture and for just drinking and cleaning. And these are, even though they're very small concentrations, they can still lead to human and environmental health problems. And it's been shown that some of the adsorbent characteristics that nanomaterials possess, along with their magnetic qualities, can actually uh, produce a solution to this contamination. So the way that this would work is essentially these nanomaterials adsorb the uh, contaminant in the water, essentially by electrostatically attracting them towards the nanomaterial. And once this happens, a magnetic field would be applied to the water, which would draw out the nanomaterial along with the contaminant. Pesticides are an essential part of the farming process. Their use allows for significantly higher crop yields and quality, so any sort of large scale operation requires their use in one form or another. The problem that they present is that they've been shown to be a concern for public health, especially due to how they're being detected in many public water supplies. But nanomaterials may also be able to help with this by employing similar methods as with the metal ions. Cobalt and nickel mixtures have been shown to be 95.5 efficient at degrading certain pesticide contaminants. And additionally, they also possess the same magnetic properties that we previously discussed. So, in conclusion, nanomaterials are probably one of the most promising technologies for the future. Their applications are going to extend farther than what I've discussed here today. Um, but they'll likely be one of the fastest growing fields in material science and engineering in the years to come.